All right, today we're going on a wild ride, tracking one of the fastest and most complicated journeys on Earth, the path of a single data packet. You know, every single time you click a link, you are kicking off this unbelievable, invisible process that happens in literally less than the blink of an eye. So let's follow the data and see exactly where it goes.
I mean, it feels instant, right? You click and a web page just appears. But in that tiny fraction of a second, an invisible, incredibly complex dance takes place across a global network. We're going to follow our data on its own little epic quest, from your computer, out across the world, and all the way back again.
So where does this all begin? Well, it starts with you, with a single click. But that simple action isn't just one big request. It's actually the beginning of a major transformation. See, to make this whole journey possible, your request, whether you're loading a web page or streaming a video, gets chopped up into smaller, more manageable chunks. You could think of it like taking a car apart to ship it overseas. It's way easier to send all the individual parts than to try and ship the whole thing at once. And these little pieces, they're the heroes of our story. Data packets. Okay, so our data's been broken down. But you can't just send it out naked, right? It needs to get properly packaged and addressed. This process has a name: encapsulation. It's kind of like getting our packet all dressed and ready for its big trip by giving it multiple layers of instructions.
What's so cool here is how each step adds a new, essential layer of information. First up, the data becomes a segment. This layer basically tells the computer on the other end which app this data is for. Like, is this for your web browser or your email? Next, it becomes a packet, and this is a huge step. It gets its destination IP address. This is like the full global street address on an envelope. Then it gets wrapped in a frame, which adds the address for just the very next stop on its local network. And finally, the whole thing is converted into bits, the actual electrical signals or flashes of light that physically travel through the wires and cables.
Our packet is all dressed up and ready to go. Its first mission, should it choose to accept it, is a small one. Just get out of your house or your local network. This is like the last mile of a delivery, but in reverse.
For this very first leg of the journey, the packet uses something called a MAC address. The easiest way to think of this is as a device's unique serial number or its fingerprint. It's not meant for long-distance travel. Its only job is to identify the very next device the packet needs to talk to right there on your local network.
And yeah, you'll often hear it called a burned-in address. And that's for a good reason. It's permanently part of the hardware, assigned right at the factory. This globally unique ID never changes, which makes it perfect for finding a specific device on a local network.
So what's actually reading these local MAC addresses? That would be your network switch. You can think of the switch as the mail carrier for your local street. It knows every house or every device on the network and uses that MAC address to deliver the packet to the right local destination. In this case, that destination is your router, the gateway to the big wide world.
And there we go. Our packet has successfully navigated the local network and made it to the router. Now it's time to leave the neighborhood and hit the vast global highway we call the internet.
Now this is a really important distinction, and it's where we see the difference between what's called Layer 2 and Layer 3 in networking. A switch at Layer 2 only deals with traffic on the same local network, but a router at Layer 3 has a much bigger job. Its purpose is to connect different networks together. It's the gateway to the wider internet. It doesn't really care about that local MAC address anymore. It's looking for that long-distance IP address.
And that brings us to the IP address. This is the big one. This is our packet's global destination, that full mailing address we talked about. It tells any router anywhere in the world the ultimate destination network where this packet needs to end up. So your router takes a look at that destination IP address, consults its internal map of the internet, and makes one simple decision. What's the best next hop for this packet? It sends it along, and the next router down the line does the exact same thing. This just keeps repeating, with our packet hopping from router to router across the globe, getting closer and closer to its final destination with every single jump.
And touchdown! Our packet has arrived at the destination server. But hold on, the job is only half done. Now the server has to figure out what you asked for and send that web page all the way back to you.
The server now does the exact opposite of what your computer did. It's a process called de-encapsulation. It's basically unwrapping the data, stripping off the frame header, then the packet header, then the segment header, layer by layer, until it gets to your original simple request. Hey, can you please send me this web page?
So the server grabs a piece of the web page you wanted, creates a brand new packet, and then encapsulates it just like your computer did, adding all those same headers. Then it sends it on the return journey.
It follows the exact same rules, using IP addresses for the long haul and MAC addresses for that final local delivery right back to your computer.
So all of those packets arrive back at your computer, get de-encapsulated, and are reassembled by your browser into the web page you see on your screen. It all happens so incredibly fast that we just take it for granted. But the scale of this operation, it's truly mind-boggling.
Trillions. It's a number that's almost impossible to really wrap your head around. But that's the estimated number of data packets crisscrossing the internet every single day. It's this constant, invisible storm of information, a silent symphony of data all following these precise rules to make our entire digital world possible.
So, what are the big things to remember from this whole journey? Well, first, encapsulation is just the process of dressing our data for travel. Second, switches use local MAC addresses, kind of like a neighborhood mail carrier. Third, routers use global IP addresses, acting like the worldwide postal service. And maybe the most amazing part? This entire process happens for everything you do online, and it all gets done in the blink of an eye.
It's an incredible system that, against all odds, just works. But as we demand more speed, more data, and more connections for everything from our cars to our coffee makers, the pressure on this invisible digital dance just keeps growing. It really makes you wonder, what's the next great challenge for keeping our world connected? Thanks for watching.